Dear colleagues and students of the AI Art Strategies course, whether you are in Budapest, Brno, or in Slovakia, this lecture is mostly a summary of topics we have already covered. As I said, the goal is to give you an inspiring starting point for your projects. I will reopen many themes, and yes, I will repeat some points. That is part of our way of approaching and reopening problems. Let us look at AI art as the opening of a completely new chapter, with the potential to change our paradigm. It leads us to the question, does art shape the future, predict it, or both? AI art can shape the future, predict it, or both. Does it not question? Does it my stage? This is mainly my artistic research position. I keep defending it, I do not force you to accept it, but I invite you to reflect on it. Any criticism of this position is a challenge for me and makes my research stronger. I am convinced that at a university a teacher should create new knowledge and teach only what they truly master. AI is a multidisciplinary effort to build systems that can perceive, reason, learn, and act, sometimes even surpassing humans in specific tasks. It belongs not only to computer science but also to philosophy, cognitive science, neuroscience, design, and the arts. Think of AI as creating new intelligent partners that extend human abilities and also raise social and ethical questions. Some people even see it as a humanity's attempt to create something that could surpass us almost like a god. In my view, it is better to keep the question of God open, and I do not mean to offend anyone by saying this. I respect different beliefs, and I speak about it only as a topic for reflection. This slide shows a selection of studies on how culture shapes our cognitive abilities. In a similar way, about 100,000 years ago, a mutation in the FOXP2 gene influenced human language use. Thanks to language, a person could learn much more about themselves from others than from their own experience. This shift supported the rise of abstract concepts like love, eternity and death, and above all, it enabled the creation of cultural artifacts. AI is not only changing our tools, it is also changing our minds. The brain is plastic, which means it can reshape itself with training. For example, London taxi drivers develop stronger navigation circuits after years of practice. People who read a lot rewire parts of vision and language. Musicians, bilinguals, and people who meditate also show clear changes in how the brain works. Even culture can influence how we think about the self and how we imagine time. Now AI is part of daily life. If we use maps for every trip, our spatial skills may get weaker, while planning and evaluation may get stronger. If we use large language models to draft, summarize, and translate, we may do less recall and more supervising, editing, and goal setting. Constant notifications can break our attention, but good design, clear prompts, time for reflection, and transparent feedback can train focus and metacognition. A mutation of the FOXP2 gene may also have triggered new processes, yes. This is a hypothesis. Exaptation means the brain reuses existing circuits for a new function. For example, behaviors first linked to calming a crying baby, singing simple tunes, while rocking in rhythm could have led to the birth of dance or music, and the excitement of positive feelings became a cultural phenomenon. Language, vision, planning, and even motor skills that first served other goals could suddenly reshape how visual art appears. Language and imagination are closely connected. The early idea of religion, like animism, may not be so far from how we now imagine artificial intelligence, because we still build AI through our natural cultural language models. Qualitative research shows that many AI art practitioners describe AI as a collaborator, a co-author, or even as an entity. In truth, we are only beginning to understand what such an entity could be. For now, it is better to see AI art as a living experiment that tests new forms of collaboration, authorship, and agency, rather than prove that these are already fully achieved. In this sense, AI as an autonomous entity remains mainly a thought experiment about cooperation. But we are not that far from the idea of a conscious agentic entity. Very briefly, the paper by Butlin argues that conscious AI is possible in theory and that we can test this by looking at what AI systems do and how they are organized. Computational functionalism gives us a clear lens. If a system has the right information processing functions, it could show consciousness. This is a research program, not a proof. We still need strict tests, shared criteria, and open debate to separate real signs of consciousness from clever imitation. Computational functionalism also sees that the substance of a mind does not matter. What matters is the organization and the functions, not that the brain is made of carbon. So, in theory, if a brain made of ice cream could realize the same computation as the human brain, it could support a mind. Why not? Today there are several influential theories of consciousness. They include integrated information theory, which is not based on computational functionalism, attention schema theory, and in my view, the most workable one, global workspace theory, or GWT. A short example comes from Rufin van Rooyen, who tries to build AI with the GWT. In this approach, many specialist modules process information in parallel, and the winning content is then broadcast to a shared workspace so that all modules can use it. Van Rooyen suggests that this architecture could give AI better planning, continual learning, and clearer explanations, and it might offer testable clues about machine consciousness. These are early prototypes, not proof of consciousness, but they show a practical path from brain theory to AI design.
I worked in the field of neuroscience of consciousness for a few years, and I've studied the different theories. And in the end, it's whichever you choose to champion. And I heard you say that you tend to favor the attention schema theory, which I really like also. I don't think it's incompatible with the global workspace theory. Yep. And my choice, like actually a good proportion, I think a majority of neuroscientists tend to favor the global workspace theory, but it remains a theory until it is proven, right? And there are different ways to prove it. You might go inside the brain and try to prove that this theory is correct. Another way to prove it is actually to implement it, to realize it in an artificial system, and see if it actually works as predicted. So it's not just a theory of consciousness, and I want to be clear about this. Yeah. It's not about creating conscious systems, at least that's not the primary objective. It's also a theory of higher level brain function, of how our brains could support advanced cognition. And that's the reason why I want to put it in an AI system, because I think we could really advance towards the next step of AI.
So we have some visuals here that I think will help flesh this out a little bit. I think you can sort of take us through these. So you have sort of a simplified version that you want to implement in an AI system.
Yeah, so the idea is that we want to connect these many different modules. So you might have a module for language, one for vision, movement, to this workspace at the center. And let's take an example where we would give a task to the system, which is walk through the jungle. And because of this task, well, first you're going to connect a movement module and you're going to start walking because that's the task. But maybe you also want to keep your eyes open because you're walking in the jungle. And so you connect the vision module to your system. That's the job of the attention system. And well, you were lucky to connect your vision module because you see a tiger appearing right now, right? And that information about the tiger, because the vision module was connected, gets inside the workspace. And once it is in the workspace, it gets broadcast to the movement module, which now thinks, maybe it would be a good idea to escape. And if your attention system is smart, in this particular situation, it might decide to keep the movement connected. You don't care so much about language, and so you're going to actually produce the escape response, which makes a lot of sense in this situation. But what's really nice about this general system is that the same system can sort of be envisioned in a different situation, where instead of walking through the jungle, you might be walking through a zoo. And you have the same modules that are connected, and at the beginning you might decide also to connect the movement because you want to walk. You also want to keep your eyes open because you're in a zoo. But in that situation, the same input, the same tiger, when it gets into the workspace, might produce a very different reaction. Now you're safe, you don't have to escape, and so instead you might connect the language module to your global workspace and say, oh, look at the pretty tiger, right? And that's an explanation for how we could build AI systems that would be flexible, that would not always produce the same output given the same input, but I could actually adapt to the environment.
And so you've attempted to do that, right? Not just in theory, to actually integrate this kind of an architecture with a large language model. So can we see some of that work? So I think this is
so we started a few months ago only, so that's why it's very preliminary, but we started building versions of the system which are very simple, right? There's fewer modules here. Right now our system only works with 2 of these modules. We have a vision module to process images, and we have typically a language module that can sometimes process natural language. We've done this with English language. And sometimes something that we call a proto-language, which is basically a mathematical language or a numerical description of the environment, if you want. And the system is trained by experience. Basically, it gets to experience images, it gets to experience language or proto-language descriptions of the world, and sometimes it gets both together. And it learns to create the right analogies between the 2 domains through its global workspace.
And so you're feeding in that data, the sensory data of all these different modalities to the system?
Yes, we're feeding in the vision data and the language data, sometimes separately, sometimes together, and it gets somehow, well, based on the way that we're training it, it figures out what are the associations that it can make between the different elements of language.
And is that supervised? I mean, is there a human being that's
So the supervision comes from the fact that the image and the language will co-occur. So they supervise each other when they happen simultaneously. But a lot of it is self-supervised because it's able to look at an image, and after a while, this image gets sent to the global workspace, and it's able to actually translate that into its own into a language version, even when the language version is not available, and vice versa.
Let me briefly repeat the starting points of Mario Klingemann, Refik Anadol, and Lauren McCarthy. Mario Klingemann, 2018 to 2024, builds artworks where humans and AI create together. He shifts the focus from the single author to a shared process with algorithms. Neural networks act like partners that help make aesthetic choices. Meaning is not fixed. It emerges in the interaction between data, changing outputs, and the viewer. Works like Circuit Training, 2020, and Uncanny Mirror, 2020, show art as a dynamic system that adjusts itself. This redefines creativity as distributed, iterative, and non-linear. Lauren McCarthy works with interactive tech, performance, and AI to test social boundaries. She looks at supervision, automation, and how digital tools change relationships. Her projects often simulate or replace human social behavior to question what feels authentic. She faces both the promise and the risks of technology, including surveillance and isolation. Key projects include Unlearning Language, 2021, which asks people to invent new forms of communication beyond standard AI and language habits, and Voice in My Head, 2023, which installs an external guiding voice in daily life. She does not build AGI, but her strategies anticipate core social and philosophical questions around it. Refik Anadol is a pioneer of AI art, who works with large datasets and machine learning. He transforms hidden patterns in data into immersive visual experiences that link digital and physical space. He calls these data paintings and data sculptures. Projects like machine hallucinations, melting memories, and unsupervised explore collective memory, cognition, and how AI can support creativity. Even if his systems are narrow, the way he fuses data, visualizes it, and creates meaning points toward how future, more general systems might work, kept necessary, because their strategies are strong examples of how to project the future. At the same time, they show that contemporary AE art is about exploration and collaboration. Artists work with AI as if it were a partner and test what shared authorship could mean. This practice imagines an entity that does not yet exist, something more autonomous than today's tools, and uses art to probe its possibilities. The result is an aesthetic of experiments, dialogue, and open futures. Let's look back for a moment and see how Hito Steyerl responded to the question of the future. She is a German artist and filmmaker who studies the digital world, surveillance capitalism, and how art is made today. In her well-known essay In Defense of the Poor Image, 2009, she shows how low-quality images travel online and still gain influence. More recently, she turned to AI in This is the Future, 2019, and the related installation power plants. She uses machine learning to generate predictive digital flowers and imagine a hopeful future. These works suggest that technology can heal as well as control, and they invite us to rethink nature, politics, and prediction in the age of AI. Yes, she names the threats, but it is artistic anticipatory research. Speculation in the best sense of the word.
This is the immediate future. I am a neural network. This is what I see.
This is the future can be condensed into more or less 2 sentences, and you can easily experience it yourself if you just close your eyes and breathe and become aware that the future starts anew at any moment. This moment is always in the present. This moment is always now.
In the future, fish will have no heads and there is water all over.
This is the future is an optimistic vision of the future in that it tries to imagine a future in which there is a lot of plans that have a lot of political characteristics or abilities. They are able to heal the present, if you like. It is definitely a vision of nature which is more optimistic than the present really allows. I do encourage everyone to pick up a piece of the pebbles on the floor because they are a special type of mineral called olivine, which has the interesting side effect of being able to trap carbon dioxide. So they can just take away this piece of pebble and do some more research in what it is able to do.
Future prediction is an old problem. People have tried to predict the future for thousands of years.
AI could theoretically be used to create positive effects. I'm very certain of that. It's very good at doing any kind of pattern analysis and so on. But under the current conditions, meaning under the current system of capitalist extraction, which is data-based, it's going to be very difficult, I guess, to achieve a lot of positive effects because most of the deployment of those technologies will go into accelerating populist division, I'm afraid, and digital extraction. I do think that there is a considerable counter-movement now against all these effects, which is pretty interesting because it is way more local than before, way more localized, also to some extent also rural and connected to the countryside. And from my point of view, it will be most interesting in the future to connect technology to this kind of movements and to integrate it within new vernacular ecological movements.
Today was extraordinarily mediocre, but tomorrow was extraordinary. More so than so-so, but still somber, I think. I looked upon an extraordinary seed grow microscopic amounts and had hope. I read the instructions.
Let's also remind ourselves why transposition matters for artistic research in AI art. A key strategy is to bring scientific methods into artistic practice. The aim is to create a work that operates like an AI system with elements of consciousness, either in a real way or as a symbolic model. This is an artistic research path toward consciousness in artificial intelligence or CAI. Yes, it is one possible hypothesis, and opening it up gives important meaning. In the broadest sense, we should see the mainstreams of AI art strategies as producing new knowledge. This follows a simple idea of artistic research, a systematic inquiry that happens in and through artistic practice and leads to a new kind of knowledge, sometimes embodied directly in the artwork, together with reflection that makes this contribution accessible and credible. Michael Schwab's important book opens space for thinking about how art can produce knowledge. Transpositions, aesthetico-epistemic operators in artistic research, maps how practice leads to insight. It brings together artists and theorists who propose operators like transposition, transduction, speculation, and reconfiguration. These are methods that move ideas across media, disciplines, and contexts. A central diagram links the chapters and treats research as a network, not a straight line. In short, it is a toolbox for thinking, making, and theorizing at the same time. One helpful idea here is polythetic classification. It means we group things by many overlapping features, with no single feature required. For example, a game can be competitive, rule-based, or fun. None of these is necessary on its own. The book does not give case studies from AI art directly, but it sits in a post-humanist frame, which makes it very relevant for how we design and understand artistic research today. I will briefly connect this to actor network theory by Bruno Latour and to my MEPAA model, which is my research project. Actor network theory says that results come from networks where people and things act together. In MEPAA, we treat the AI system as an agentic entity, and we map how data, models, prompts, sensors, artists, curators, and audiences translate each other's interests. Latour's ideas of translation, mediation, and black boxes help us record provenance, expose hidden choices in datasets and code, and assign responsibility. This supports MEPAA's goal to study aesthetic processes and to test future forms of human-AI partnership. In short, ANT gives MEPAA a method to trace relations, and MEPAA turns those traces into experimental protocols for artistic practice. Here we arrive at speculation as a legitimate tool of artistic research, an anticipatory instrument for the future. It lets us test possible worlds, surface risks and opportunities, and rehearse choices before they become real. Let me briefly remind you what the MEPAA model is. The MEPAA model, model of experimental speculative aesthetic processes in AI art, studies how humans and AI create together and how this changes art. It stands on 3 pillars. First, AI art as a developmental stage with the latency of an agentic entity. Second, artistic research strategies with an anticipatory potential that test near futures. Third, a speculative-predictive model that turns ideas into protocols you can actually run. In practice, this means clear data provenance, declared models and prompts, logs of human-AI interaction, and simple measures for reflection. The goal is straightforward. Use experiments to understand aesthetic processes today and to prototype responsible human-AI partnerships for tomorrow. To understand what a speculative approach really is, let's start from the basics. Anthony Dunn and Fiona Raby use speculative design to explore what-if futures, not to make commercial products. They build scenarios and props called diegetic prototypes that help people talk about the social, ethical, and political effects of new technologies. The goal is not to predict the future, but to spark debate, challenge assumptions, reveal values, and open several possible futures. The methods include writing narratives, mapping key drivers and weak signals, and designing artifacts that feel real enough to test our reactions.
I think that visions of the future serve many different purposes. Often they're used, say, within industry to try and set a direction, or as a form of propaganda to open up new markets or to test ideas. And with speculative design, it was always trying to decouple it from that sort of agenda, and not to say, here's a vision we should try and pursue and implement, which is where a lot of confusion happens, but rather, here's just a very different way of thinking about reality or the world or social relations. Yet let's use that as a catalyst to spark further thinking and imagining. And I think that's it sounds pretty obvious, but it's quite a subtle issue, and it gets lost, I think, a lot in the ways that speculative design gets interpreted.
Let me walk you through this map of the speculative approach in plain language. The left side is about small improvements to what we already have, while the right side is about big system-level change. The bottom is open and exploratory. The top follows clear goals for strong sustainability. Strategy and innovation live on the left with practical near-term steps. In the middle, design stretches from small tweaks to bigger shifts. At the top right, transition design and anticipation studies try to guide society towards sustainable futures. At the bottom right, speculative design, design fiction, world building, and science fiction open our imagination without telling us the right answer. Now, the core of a speculative approach. First, we ask what if, and explore several futures instead of making one prediction. Second, we build stories, images, or prototypes that feel real enough to provoke a reaction. Third, we surface hidden assumptions and values, both risks and opportunities. And fourth, we keep it open. The goal is debate and learning, not final truth. For AI art, this means using artworks to test futures with AI, to show possibilities, reveal problems, and help us think before those futures arrive. Now let me introduce a case. Emilia Tica and Lea Perraudin ran a speculative design workshop during Berlin Science Week to imagine new ways of making materials and to connect scientists with the public. Instead of giving answers, they asked what if questions and treated everyday materials as active and alive. Participants built futures from early research ideas, not finished technologies, to explore possible social effects. This bottom-up format turned science communication into a shared conversation where anyone could speculate and contribute. The workshop What is the future made of? Created an open space for equal exchange between research and society.
If we think about materials as active and alive, where would that lead us in sense of everyday objects, everyday rituals, like how the society is formed? My name is Emilia Tikka. I am a designer, researcher and filmmaker. And my practice is based on a field of design which is called speculative design.
My name is Lea Perraudin and I'm a postdoctoral researcher at the Cluster of Excellence Matters of Activity at Humboldt-Universität zu Berlin. And I am the co-leader of the project Collective Materials. My vision for this project is to co-create a space where people from the public and researchers from our clusters can exchange on eye level. Collective Materials is a project where we engage together with different people from the public about questions of materials, of our material futures. And we want to ask each other how the materials of our futures could look like, what relationship we have to them.
You know, in modernity, you took the materials as something passive and perhaps even passivated them with technology, if you think about plywood or concrete. And we were trying to imagine like how the future would look like if you would take the materials as active and as alive and with their own agency that you could perhaps collaborate with. So this kind of different relation to materials was the core idea of the workshop. So the participants of the workshop should imagine what kind of everyday objects of this bio-inspired world with active materials or living technologies could look like. And later on, we kind of went from more abstract ideas towards this kind of everyday objects that would be then exhibited in the exhibition, and you know that would then encapsulate how the speculative future could look like. So it was kind of a mixture of first thinking things individually and then bringing that into a group and thinking further as a group.
We just had our first public speculation event with Collective Materials, so there are some quite fresh expressions from this experience. We were gathering in small groups and we didn't know each other before, so we were just this ad hoc community of speculators.
So usually you take scientific research that is not yet developed as a technology, you accelerate it into the future and imagine what kind of societal impacts this technology might have in the future when it has become an everyday application of the technology. And you take these ideas in today as objects, as materialized ideas of that societal change. So there's kind of the classical pattern of how to do speculative design. In the essence of speculative design, there's also this idea that it should never become kind of an pinned down method, because it is that kind of field of design that goes against that idea, you know? So it is kind of the rebel in design. So when it becomes a method that, you know, it kind of loses something. So it should be always in shift, always in change. That's kind of the essence of this way of making. I'm really interested of bringing speculative design as something that can engage people and have this idea of more inclusive scientific futures.
We really see some great potential in applying the method of speculative design for science communication, because it takes the process of how we take a piece of research or some findings as an impulse, but it also asks about attached questions that are yet unthinkable. What I really like about speculative design in this sense is that it challenges us to step a bit out of our habits and our usual way of doing things, and maybe even leave behind a bit like this idea in our self-understanding as researchers. What is this new approach to materials about? We are using the method of speculative design as a means for science communication. Science communication is really at the center stage of this endeavor. We need public engagement and an exchange on questions of materiality and material futures because they apply to all of us.
The science communication in a classical sense has been about educating people about science, and within this project we thought that maybe we could find a way where the participants could be in a more active role. Through speculative design you can really make these ideas and futures and questions tangible that people might have. It's not about finding solutions, it's rather about asking new questions.
We believe that this new approach is also necessary to tackle some of the most pressing and urgent ecological challenges of our time.
To ask better questions and to start teaching AI or pushing our own limits, let's make prototypes. A prototype is a provocative prototype, a quick, believable object, scenario or story made to spark debate, not to fix a problem. It shows a what-if future so people can react, question values, spot risks, and imagine alternatives. Every speculation needs some grounding, and the futures cone is a simple way to frame talk about conscious AI. In the probable zone, AI stays a tool, maybe a powerful one, but not an entity. In the plausible zone, systems gain global workspace style attention, memory and self-monitoring. Collaboration feels more agent-like, but we need strict tests so we do not confuse as if with the real signs of consciousness. In the possible zone, richer world models and longer-term goals could show clearer markers of consciousness. To prepare, we should combine lab experiments, thought experiments, and speculative design, using prototypes and stories to probe ethics, authorship, responsibility, and limits of partnership. This proposal sketches a speculative-predictive model for AI art, the MEPAA model. It combines two vectors. The first is a predictable vector based on data-driven trends and current limits. The second is a speculative vector that asks, what if, and opens new scenarios. Together they set the frame to explore future aesthetic processes where an agentic entity might take a leading role. The model guides experiments, prototypes, and the way we evaluate agency, autonomy, and co-authorship in human AI practice. This slide offers inputs for thinking about the future of AI art. Metaculus stands for the predictable vector, aggregated data, and community prediction scores. We then layer in expert judgment, technical insight, social factors, and profit incentives. Where these layers overlap, we get grounded scenarios about AGI and its impact on aesthetics. The idea is to mix hard forecasts with context so we can guide experiments and policy in AI art. A quick caution, platforms like Metaculus or Polymarket do not give responsible signals by themselves. They combine many small forecasts, a bit like ensemble learning, so you got calibrated probabilities but not ethics, culture or accountability. Use them as one input only and balance them with expert review, artistic research, and clear norms on safety, bias, and authorship. AGI, Artificial General Intelligence in Art, means AI that works across media, combines skills, and transfers them to new tasks. It adapts on its own, sets goals, plans steps, learns from feedback, uses tools, and works with incomplete information. It also shows dependable understanding with self-reflection, causal and social reasoning, awareness of uncertainty, values for safe behavior, and clear, auditable explanations of its actions. The aim is robust, accountable human-AI co-creation. An agentic entity is a system that can act on its own. It perceives a situation, sets or adjusts goals, chooses among options using its internal model, and learns from outcomes. In simple terms, it has aims, makes decisions, adapts over time, and interacts with the world by taking actions and using feedback to improve. In the MEPAA model of experimental speculative aesthetic processes in AI art, an agentic entity means AI can take partial initiative in making art. It reads inputs like data, context, and instructions. It proposes or adjusts goals such as style, composition, or dramaturgy. It picks methods like models, tools, and prompts. And it learns across iterations. Practically, this adds clear roles. AI as co-author, data curator, experimenter, indicators of agency, planning, step-by-step explanations, handling, new situations, stable behavior across context, protocols, logging data provenance and edits, redo and ablation tests, comparisons to a human baseline, and evaluation, aesthetic and cognitive measures like originality, coherence, auditability, plus risks such as bias or hallucination. The speculative-predictive axis then models how rising agency could shift authorship, responsibility, and rights. In short, MEPAA asks a focused question: when does AI stop being only a tool and become a working partner with verifiable signs of agency? We make schemas to turn complex ideas into something we can see and discuss. A mob shows who and what acts in an AI art process: data, models, prompts, sensors, artists, curators, and audiences. It also shows how they connect. This makes hidden choices and values visible. A schema is not only documentation, it is an aesthetic process on its own. The form of the map shapes how we think, plan, and create. It helps us design experiments, build prototypes, and test agency, authorship, and autonomy. It supports good practice, clear data provenance, traceable steps, and accountable decisions. In short, schemas are tools for seeing, thinking, and making. They guide action today and open credible paths for future AI art. The lesson is simple. Practice shapes the brain. If AI changes what we practice, it will change our brains too. So let's choose and design AI that builds curiosity, judgment, empathy, and creativity, not only speed and convenience. The future of intelligence is not human or machine alone. It is a partnership that shapes who we become. Through remediation, it is possible to add properties to a work that may correspond to future AGI. The existing piece is first decomposed into modules, data, instructions, interaction protocols. The participant wears headphones and listens to instructions in real time. AI or a performer whispers what to do or say. This voice temporarily replaces the participant's inner monologue. The project examines questions of autonomy, agency, subordination, and trust, while also mapping the emotional and psychological effects of continuous interaction with technology that intervenes directly in thinking. Remediation in new media and AI art means transferring the formal logic of an older medium, its timing, resolution, interface, and distribution protocols into a new computational or algorithmic setting. The trace of the source medium stays visible, but its parameters change. Interactivity grows, elements become modular, and the work behaves like a database. This activates a double logic, immediacy and hypermediacy, at the same time. In the MEPAA model, remediation works as an indicator of latent agentic entity. because the system takes over and modifies the rules of another medium. It is also a research procedure that uses protocols and allows metrics such as frames per second, latency, compression artifacts, and layers of the user interface. It functions as a speculative predictive test of future aesthetic modes of perception. It is different from appropriation because it transforms the form and the protocol, not only the motifs. It requires that the source medium remains readable and that there is a measurable parametric change. In one sentence, remediation is the experimental remapping of a medium's logic into an algorithmic environment charged with agency in order to make mediation visible and to test future aesthetic protocols. Based on a strategy algorithm from my original project Voice in my head, and using selected AGI-like elements, I developed dozens of remediation proposals, reworked versions translated into new media and methods. Each one is a small experiment that checks how AI can change authorship, the creative process, and the audience experience. Here are the core research and epistemic questions for AI in my project, and we can safely generalize them. First, which modes of cooperation between humans and a near AGI, a near agentic entity, create distinct aesthetic processes and how can we measure them? Second, what new aesthetic processes do these systems enable? And how are they different from human practice and from standard algorithmic workflows in art? The aim is to set clear indicators, methods, and comparisons so the differences are visible, untestable, and meaningful. One impulse for me was Douglas Gordon's Play Dead, Real Time, 2003. In that work, an elephant performs in an empty gallery, repeatedly lying down as if dead, while robotic cameras circle and record. The piece stages vulnerability, training, spectacle, and control all at once, and it makes us feel the gap between what we see and what the animal might feel. That led me to a question for AI art. Where are the limits of translating emotion across species? This project links human and interspecies emotions through artistic research, cognitive neuroscience, and AI. In Douglas Gordon's silent video Play Dead, Real Time, a participant watched without speaking while an AI tracked their feelings every 5 seconds: empathy, fascination, sadness, curiosity, uncertainty, to create a time-based emotion map. We then matched these human states to vocal expressions of grieving elephants collected from public videos using multimodal analysis. The outcome is a 4-minute sound piece that pairs human emotion categories with elephant calls. It proposes a transpositional model of affective continuity across species and opens a new conversation about aesthetics and empathy in contemporary art. The project starts by collecting signals, video, audio, movement, and context. We train models on these data, then add an alignment layer for safety, ethics, and clear explanations. People stay in the loop through simple interfaces and a co-learning UI. Biofeedback helps the system focus on the right cues. We test in real settings, monitor welfare, and evaluate results for accuracy, coherence, originality, and auditability. Governance tracks provenance, permissions, and responsibility so the workflow is repeatable and accountable. Let me introduce another test research project from 2023. Me Recall. V1 is a speculative piece about a dialogue between a person and their AI self. I built a generative model called Model ME from personal materials like texts, emails, and family stories. While the AI speaks short lines, and in a second version, lines paired with music, I record the person's facial expressions and map them onto a poetic 3D brain. The work compares the lived self with its AI reflection and asks what identity, memory, and emotion look like when filtered through a model. Future versions may add non-invasive neural decoding to probe inner speech. The aim is an atmospheric exploration of AI-mediated selfhood, not a technical proof. Theory of mind in AI means estimating human mental states and using those estimates in decisions. A system should reason about what someone knows or believes, spot false beliefs, and adapt its plan. We test this with false belief tasks, scenes with hidden information, and multi-agent games. Today, large models can simulate parts of this from text, but they often fail outside familiar patterns. Their understanding is fragile and depends on prompts and data, so this is not evidence of real consciousness. Exaptation means the brain takes an existing circuit and uses it for a new job. Reading is a good example. A visual area that once helped with shape recognition now helps us read words. Something similar happens when navigation circuits support abstract reasoning, or when the cerebellum's motor prediction supports cognitive prediction. If practice shapes the brain, then using AI every day can shape it too. I have 3 short predictions. First, long-term power users of large language models will build stronger networks for monitoring and metacognition. They will get better at quality control and error detection rather than raw recall. We can test that with long-term fMRI or EEG and behavior while people solve tasks with and without AI. Second, AI-augmented senses, like computer vision navigation for the visually impaired, will reorganize perceptual and associative regions. It should look like the changes we see when people learn to read. We can test it with training groups and connectivity measures. Third, a trade-off may appear. With heavy cognitive offloading to AI, maintenance memory may weaken, while strategic reasoning gets stronger. Exaptation-driven neuroplasticity should be an explicit component of any predictive model for AI art. Anticipating future aesthetic processes requires modeling not only technical trajectories of AI systems, but also systematic changes in human cognition that arise from new habits of use. Exaptation implies that prolonged AI-mediated practice can reassign or refine neural circuits, monitoring metacognition, multisensory integration, thereby altering attention, memory strategies, and evaluative judgment at the very substrates of aesthetic experience. Consequently, forecasts of authorship, agency, and reception must treat human-AI coevolution as a coupled system. As AI architectures advance, human brain use patterns adapt in parallel. Incorporating these reciprocal adaptations with empirical markers such as longitudinal behavioral motorics and neuroimaging proxies improves anticipatory validity and grounds scenarios about emerging aesthetic protocols, practices, and norms. On the right, you see the Budapest reference connectomy, only like a better imagination. It is a consensus brain network built by combining the structural connectomes of many healthy people and keeping only the connections that show up reliably across individuals. The team released open datasets and an interactive tool, so you can set thresholds and weights and run reproducible comparisons between groups. While making these references, they noticed an ordered pattern in how the most robust connections appear over time. They called this consensus connectome dynamics, and it opened a new line of research on the brain's structural organization. Thank you for your attention.